Let's go ahead and look at the other two types of equations. We've already looked at simple addition and simple subtraction equations. Let's look at multiplication and division now. So let's go ahead and let's say that we have 2x and it equals 12. This is going to be a super simple one to start off with. Remember, when we have a number and a variable that are squished together without any spaces, then we actually have a multiplication problem there. It actually represents multiplication. So we can look at 2x and realize that's 2 times x. If you needed to put in parentheses to show that that was 2 times x, or you needed to put a multiplication sign or a dot, you could totally do that. Just remember that when they are squished together as a coefficient, which is what that 2 is, telling us how many x's, and a variable x, it actually means multiplication. So right now we have 2x equals 12. So remember, if we were looking at this on a pan scale, we would say that whatever x was, there would be 2 of them. And we're saying that 2 of those x's equals 12. Okay, now, if we went ahead and we were trying to solve this, we need to remember get x alone because we want to figure out what that last piece or that last numeral is over on the right, that simplified numeral over on the right, when there is only an x on the left, or vice versa, so that we can figure out what is actually equal to x here. Now, right now, 2x equals 12. Well, if there are 2 x's, then that means that there are 2 groups of the same number represented on the right side as well with the number 12. So what we need to do here is we need to break that group into 2 pieces to see how much is actually in one of those groups. How? We do the opposite of what's listed here. So right now it says 2 times x. Well, if we want to do 2 times x, and we want to get rid of that 2, we need to divide. So let's divide by 2. 2 divided by 2, and mind you, we're only dividing the 2 away. We're not dividing the x. We're only dividing that 2 away. 2 divided by 2 equals 1. So in this case, whenever we write a variable that only has one of them, we never write 1 and then our variable, 1x, 1t, 1q, 1r. We don't do that. It's not efficient. So in this instance, we're just going to say x is left over. So remember, if we're dividing by 2 on one side, meaning we're taking our groups and breaking them into 2, we're getting rid of one of our 2 groups. That means we need to do the same thing on the other side. So we have already divided by 2 on the left. We're going to divide by 2 on the right as well. 12 divided by 2, which means we're taking 12, breaking it into 2 even groups. Which is going to be 6. If I would have written my tallies differently, I could have circled them for you. This would have been an equal group of 6. And then, whoop. This would have been an equal group of 6. We're getting rid of one of those groups. And we are left with 6. 12 divided by 2 is indeed 6. So if we rewrote our problem and put in instead the new value of 6, we would have 2x equals 12 instead of x, which, mind you, is multiplication right now because they're smushed together, that 2 and x are multiplication. We are going to put in our new value of x because we had x left over, and 6 representing the right side since we broke it into 2 groups. We are going to put in a 6 and multiply. Remember, parentheses is another way with numbers to show you're doing multiplication. 2 times 6, if I solve my left side, is indeed 12, balancing out the other side of my equation with 12. All right, let's do one more of those. Let's do x over 4 equals 7. So what we're saying is whatever x is, we are breaking it into 4 equal groups. And that is going to represent 7 on the other side. So we're taking one of those 4 groups and that equals 7. Whatever that group is, that x is, that variable is representing, we don't know yet, so we're going to figure it out. So right now this is division. We know that fractions can be, or division problems can be represented as fractions. And in this case, we have x divided by 4. Well, what if we weren't dividing? What if we did the opposite? If we do the opposite, then we can actually balance our scale out to get x alone. So remember, your goal is to get x alone. So instead of dividing here, I think I'm actually going to multiply. I'm going to multiply by 4. So that I can get x by itself. So we're looking at 4 now divided by 4. 4 divided by 4 is going to be 1. We multiplied on the left side to cancel out that division of 4, division by 4, excuse me. So now we need to multiply by 4 on the opposite side as well. 7 times 4 is going to be 28. And the only thing that's left on our left side is x. Let's plug it in to see if that indeed is true. 28, which is x, divided by 4 equals 7. 28 divided by 4 can be written as 7, which really does balance out the right side of our problem. Let's see one more of those really quickly. All right, let's look at x divided by 3 equals 300. All right, so what we're going to do, remember, is we are going to try to get x alone. Right now we're dividing by 3, and in order to get rid of that 3, we need to multiply it away, multiply it by 3. Multiply is the opposite of division, which is what we have over here on the left. That's the only way to get rid of it. A multiplied 3 on the left with a division by 3 on the left also. They cancel out. If we do a multiplication on the left side, in order to balance our scale, we have to do it on the right side as well. 300 times 3 is 900. The only thing left on the left side is x. Let's go ahead and plug it in, see if that is correct. It would be x over 3 equals 300. Remember, x is actually not just x anymore because we have solved it. We have said that it is actually 900. All right, so we can solve the left side of our equation to see if this is true. 900 divided by 3 is actually 300. They are indeed balanced.